Today we are solving LeetCode 493 reverse pairs. This is a hard problem, but do not worry. We will break it step by step. In this problem, we will learn 5 important DSA concepts. First, pair counting in arrays. Second, why brute force fails for large constraints. Third, merge sort as a divide and conquer technique. Fourth, counting cross pairs using 2 pointers, and we have to be careful with indices, mid plus 1, boundaries, and strict comparisons. This problem is also very close to the famous count inversions problem. In count inversions, we count pairs where nums at the index I is greater than nums at the index j. But here, the condition is slightly different. Nums at index I, number at index I is greater than 2 times the number at index j. So today our goal is not just to solve this problem but to understand the pattern behind it. Let's switch to the problem statement. So we are given an integer array, nums. We have to return the number of reverse pairs in the array. A reverse pair is a pair of indices I, j such that I is less than j and nums I is greater than 2 times nums j. So there are two conditions. First, I must come before j. And second is nums I is greater than 2 times nums of j. That is, the value at index I must be greater than double the value at index j. Let us understand with an example. So let's take nums equals 1, 3, 2, 3, 1. The valid reverse pairs are 1, 4. That is index 1 and index 4. So this is because nums 1 equal to 3 and nums 4 equal to 1. And 3 is greater than 2 times 1, 3 greater than 2. This is true. Another valid pair is index at number at index 3 and number at index 4. Because nums 3 equal to 3 and nums 4 equal to 1. So 3 is greater than 2 times 1. This is also true. So the answer is 2. Because we have to give the count of reverse pairs. We are checking nums I greater than 2 times nums j. That 2 times is the most important part of this problem. Let's go with the brute force method. So the simplest way is to check every element. For every index, the simplest way is to check every possible pair. For every index I, we will check all indices j after I. So j will start from I plus 1. Because the condition says I less than j. That's why I plus 1. The brute force code will look like this. So we initialize count equal to 0. Then we run the loop for I in range n. Then an inner loop for j in range I plus 1 to n. And then we check the condition if nums I is greater than 2 times nums j, count plus equal to 1. This is very easy to understand. We are checking all possible pairs one by one. But the problem is time complexity. The outer loop runs n times. The inner loop also runs almost n times. So the time complexity is order of n square. And if we look at the constraints, then we can conclude that this algorithm is very slow. This n square will be too slow. So brute force is logically correct but not accepted. We need an optimized solution. So now let us think. The problem is asking us to count pairs. The condition is I less than j and element at I is greater than 2 times the element at j. Whenever we see a pair counting problem, but brute force is too slow. We should think, can sorting help? But we cannot simply sort the full array directly because sorting changes the original positions. The condition I less than j depends on original index order. So we need a technique that keeps track of order while also using sorting. That technique is merge sort. So merge sort divides the array into two halves. So yes, merge sort can help. What it does, it divides the array into two halves. For any range, nums left to right, this is our uh, array that we want to sort. We divide it into two halves. Nums left to mid and nums divide into the two halves. Now reverse pairs can be of three types. So first is both indices are inside the left. And second can be both indices inside the right half. And third can be I is in left half while j is in right half. And this can be termed as cross pairs. The first two types will be counted recursively. The third type is the important one. So at every step we do three things. Count pairs in left half, count pairs in right half, count cross pairs between left half and right half. Then we merge the two sorted halves. Suppose after recursive calls, both halves are sorted. So let's assume how to count cross pairs. Let's assume two halves after recursive calls are sorted. So left half is nums left to mid and right half is nums mid plus 1 to right. We need to count pairs where I is from left to mid and j is from mid plus 1 to right and nums I is greater than 2 times nums j. Because both halves are sorted, we can use two pointers. We keep one pointer I in the left half, we keep another pointer j in the right half. For each I we move j while this condition is true. Nums of I is greater than 2 times nums of j. So for each I we move j while this condition is true. When this while loop stops, it means all elements from mid plus 1 to j minus 1 were valid for this I. So the number of elements becomes j minus mid plus 1. This formula is very important. Why? Because the right half starts at mid plus index mid plus 1. If j has moved ahead, then valid right side indices are mid plus 1 till j minus 1. These are the valid right side indices. So total valid indices becomes j minus mid plus 1. These are valid right side indices and total indices, total number of indices becomes j minus mid plus 1. This is where many beginners get confused with plus 1 and minus 1. We should be very precise here. Also, we do not reset j for every I. Why? Because the left half is sorted. As I moves forward, nums I becomes larger or equal. So if some right side elements were already valid for a smaller left value, they will also remain valid for a larger left value. That is why j only moves forward. This makes the counting step linear. Now let's write the pseudocode. First we create this function reverse pairs, which will return me the merge sort from 0 to n minus 1, n minus 1 being the length of the array. Then we write merge sort function. It takes two indices, left and right. We write the base case. If left is greater than equal to right, we return 0. Because it is already sorted, what we are returning is the count of the reverse pairs. So it is already, there is a single element, so there cannot be any reverse pairs. Else we make mid equal to left plus right, double slash 2. Then we write initialize count equal to 0. Then we increase the count by recursively calculating in the left array. And similarly we calculate the number of reverse pairs in the right half. Then we count the cross pairs. Then finally we merge the left and right half. And at the end we return the count. Count indicates number of reverse pairs in this array range. Number of reverse pairs in this array range. Next we write the count cross pairs function. So it accepts three parameters, left, mid and right. We initialize count equal to 0 and j equal to mid plus 1, the first element of the right half. Then we run the loop for I from left to mid. We keep on increasing j till the condition holds true. When this inner loop ends, we increase the count. Finally, we return the count. Now we merge the array left and right array, left and right halves. So it takes three parameters: the first index of the left half, the first index of the last index of the left half, and the first index of the right half. So we create a temp array. Then we initialize I and j. I is the first index of the left half, j is the first index of the right half. Then while I is less than equal to mid and j is less than equal to the right, that is the last till the last index, put a smaller element into temp. Now we copy the remaining left half and remaining right half. Finally, we copy temp back into nums left to right. So that is it. This is our pseudocode. Now let's write down the main Python code. So we will create one function, merge sort. Write the base case like we did before. Then initialize the mid and the count. Then we count reverse pairs recursively and in the left and right half. Then we count reverse pairs where I is in the left half and j is in the right half. So we are not creating a separate function, but we are doing in the same one function. So we initialize j equal to mid plus 1. Then we run I from in the left half of the array and j in the right half. Now we start increasing the if valid j indices are from min plus 1 to j minus 1. So number of valid elements equal to j minus min plus 1. Now we have got the count of the reverse pairs in the where I lies in the left half and j in the right half, cross pairs. Now we merge the sorted left and right half. So we are not writing a separate function for merge, but we are doing merge right away inside this. So first we run run the while loop where I is less than equal to mid and j is less than equal to right. Then we copy the left or right elements when the loop ends. One of this will run. Finally, we copy the values back in the original original array and we return the count. And we also return the merge sort. So this is our merge sort function, and here we call the function. Let us try run this example. So initially left equal to 0, right equal to 4 and mid equal to 2. So the array is divided into left half and right half like this. Merge sort will recursively sort both halves. After recursive sorting at the top level we will have left half equal to 1 to 3. So after recursive sorting and right half equals 1 comma 3. Now we count cross pairs. So here now count cross pairs. So here left equal to 0, mid equal to 2 and right equal to 4. So left half indices are 0 to 2 and right half are 3 to 4. We start j equal to mid plus 1 equals 3. Now we check each I. For I equal to 0, we have nums I equal to 1 and nums j equal to 1. 1 is not greater than 2, so it is false. This is false. So j does not move. Valid right side elements are j minus mid plus 1. That is 3 minus 3. So j minus mid plus 1 equals 3 minus 3 equal to 0. For I equal to 1, nums I equal to 2 and nums j equal to 1. Now we check. Again it is false. So this is false because the condition is strictly greater. It is not greater than or equal to. So again j does not move. Count added is again 0. So j minus mid plus 1 equals 3 minus 3 equals 0. Because j does not move. Now for I equal to 2, nums I equal to 3 and nums j equal to 1. So 3 greater than 2 star 1, 3 is greater than 2. So this time it is true. So j will move. So j equal to 4 now. Now let's check again. This time nums j equal to 3 and 3 greater than 2 star 3, that is not true. This is false. So now j does not move. Now we add mid plus 1 to j minus 1. So that is j minus mid plus 1 equals 4 minus 3. J minus mid plus 1 equals 4 minus 3 equals 1. So at the top level we found one cross pair. The other reverse pair was already counted inside the recursive left or right half. Final answer becomes 2. So the output is 2. Now let's check the time complexity. Merge sort divides the array into two halves again and again. So the number of levels is log n. At each level we do two linear operations counting cross pairs, merge sorted halves. Together each level takes order of n time complexity. So total time complexity is uh, order of n star log n log n. Now space complexity is order of n because we create one temp array for merging. And the recursion stack uses order of log n. But the main extra space is the merge array, so we say order of n. Now we can submit the solution. Let me comment it out. So it is accepted. Let's now submit it. So it passes because we reduce the time complexity from order of n square to order of n log n. This is why merge sort is so powerful in pair counting problems. Now let's discuss the critical mistakes that people generally do while solving such problems. First mistake is checking the wrong condition. Do not check num psi greater than num j. The correct condition is num psi greater than 2 times num j. The second mistake is using greater than equal to. The condition is strictly greater than, not greater than equal to. The third mistake is resetting j for every I. We should not do that because both halves are sorted. J should only move forward. The fourth mistake is counting with the wrong formula. The correct formula is j minus mid plus 1, not j minus mid and not simply j, because the right half starts exactly at mid plus 1. The fifth mistake is merging before counting cross pairs. We should not count cross pairs first. We should count cross pairs first, while the left and right halves are separately sorted. Then we merge them. The sixth mistake is forgetting integer overflow in languages like Java and C++. In Python, integers are safe, but in Java or C++, 2 times numj can overflow. So there we should use long or long. Okay, so today we solved LeetCode 493 reverse pairs. We started with brute force, where we checked every pair. That took order of n square. Then we optimized it using merge sort plus 2 pointers. The main idea was divide the array, solve left half, solve right half, count cross pairs, and then merge. The most important learning from this problem is that merge sort is not only used for sorting, it can also be used to count special pairs efficiently. This pattern is very useful in many advanced array problems. So whenever you see a problem asking to count pairs with index order and brute force is too slow, remember this idea. Divide, count, merge. That is it for today.